We're going to make it into the square root of u over u minus 2u squared over u, right? What's the square root of u over u? U to the what? Yep. Minus 2u du. Now you just what? Anti-differentiate. Now you take the integral. So it's going to be u to what power? 1/2. So what do you have to put in front of the u? A 2 minus u squared, and we're going from 1 to 9. Say the bottom one first. From 1 to 9. Exactly. So it's going to be 2 times the square root of 9 minus 9 squared minus 2 times 1 minus 1 squared. So what are you going to end up with? 6 minus 81 minus what? So what's that going to be? How many people got negative 76? Yay, negative 76. Excellent. Don't forget, you can simplify these. You don't have to make them more complicated. Just because you see a fraction doesn't mean you're undoing the quotient rule. If you see a fraction, your first thought should be, can I simplify this? That's actually should be your first thought anytime you do a math problem. Is there a really easy thing I can do to simplify this to make my life much, much, much easier? So don't forget, you can simplify. Yay. You can't distribute it because it's to the 5th power. So no, we shouldn't do it. So what's one thing you could do that you really shouldn't? Multiply it out. Please don't multiply something to the 5th power out. Just don't do that. I mean, it'd make the integration really quick, but no, doing that's just going to be really annoying and you will get it wrong. What method do you need to use, Mariah, to do this? You told it. You said it out loud a second ago. What method do you need? Oh, what do you need to use? What method? What? You're integrating. Chain rules for differentiation. What method do you use? What kind of substitution? I think you've called it u-substitution. Yes, so in this case, the key to u-substitution is, and that writing is just terrible. I'll just call it u-sub. If we use u-sub, it's choosing the proper one. Sometimes you're not going to choose the proper substitution. Sometimes there isn't a nice substitution. But in this case, what substitution should we use? Plus 1. So what does du equal? What does du equal? When you take the derivative of both sides, what do you get? 2y dy. Y prime, yeah. So let's isolate dy, and what do you get? Du over what? 2y. At this point, what do you do? At this point, what do you do? What do you do next? Plug in. You just plug in what you know. So you're having an integral y times what? What is this? U. That's u. So y times u, correct? But what's dy? This is where the magical thing happens. What magical thing happens that you're so happy about? The y's cancel, and you're left with the integral of, you plug the 1/2 outside, u to u du. What have I not written into that integral? There's no, oh, to the 5th. Thank you. Yeah, that's actually kind of important. What else haven't I written in? The integration what? What are they called? What are they called, Eli? I have not written in the limits of integration. This is really important. This is a very, 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 very common mistake to make. Are the limits of integration still 0 and 1? No, they're not. Once you substitute in u, these right here are values when you're integrating with respect to y. We are no longer integrating with respect to y. We're integrating with respect to u. What does u equal? Y squared plus 1, right? What is, when you plug in 0, what do you get? 1. And when you plug in 1, what do you get? You're integrating from 1 to 2. Biggest mistake, probably the most common mistake on u-substitution, besides just totally breaking down in algebra land, is forgetting you need to change the limits of integration. So what do you do now? So 1/2, what's the integral of u to the 5th? 1/6 u to the 6th from 1 to 2. So what do you get? 1/2 times, actually you can bring out the 1/6, right? So 1/12 times what? 2 to the 6th minus 1. I could simplify that. I don't really want to. What's 2 to the 6th? What's 2 to the 6th? 64. So it's 63 over 12. Done. That's it. This is a nice and helpful method because are we substituting back in for u? At the end here, did we plug y back in? No, we didn't because we changed the limits of integration. We changed the limits of integration, so we do not need to substitute back in. Can you if you want to make the question longer and harder? Sure. You don't need to, though. You don't need to. This is u-substitution. This is one of the only methods that's new for you, relatively new for integration. That's it. Claire? 1 minus x is going to be to what power? In the integral. When you integrate this, it's going to be raised to the... What's the integral of x squared? What's the integral of x squared dx? 1/3 x to the third. So I ask again, when you integrate 1 minus x, what's the power going to be? 10, correct. So if 10 is there, what are you going to have to put out front? 1/10. 1 minus x, what's the derivative of 1 minus x? So what are you going to have to park out front to take care of that negative? A negative. There it is.
So it's basically just similar to like the chain rule.
You're taking care of the problem the chain rule brings up, which is if you differentiate this, a negative sign will get popped out, but you don't want it to be negative, so what do you put out there? Put a negative out there. Exactly. Great. Yeah. Correct.
So does this work like if it's more complex?
Substitution, you just need to make a good guess and go with it. What do you think the u substitutions should be? Someone raise their hand and tell me what we should make u equal to. Yeah.
1 plus 1.
Yeah. Things underneath the radicand are likely targets. So what's du equal, Daniel?
1.
Nope.
Or, no. 3.
Yeah.
3y
Times y prime. Yes. Exactly. So what does dy equal?
Du divided by 3y squared.
Yep. So now what do we do? Yeah, we plug in. We substitute. We substitute. Exactly right. So we substitute. It's the integral of y squared times the square root of what? U. And instead of dy, we write du over what?
3y squared.
What's the magical thing that happens that makes this whole... this cancels. If the y's didn't cancel, you can't go any further. Because if you have y and u, do you have any way of integrating that? Nope. So you have 1/3 the integral of u to the 1/2 du. What have I not written in? The limits of integration. The limits of integration were going from 0 to 2, but now they're going from... Now they're going from 1 to 9. 1 to 9. U is equal to 1 plus y squared, y cubed. Oh, y cubed. Y cubed. So, yeah, 1 to 9, yeah. Y, u, plug in 0, what do you get? 1. Plug in 2, what do you get? That's it.
Okay.
Really simple step that gets missed all the time. So you get 1/3 times the square root of 9 minus the square root of 1. So that's going to be 2/3. All done. Yay, exciting, huh?